moving to your project. Okay. The first step was actually to record your audio. By the way, you can record your audio on MATLAB. So recording the voice or audio. And you can do that on MATLAB or any other tool and then take it into MATLAB. One thing that you will notice is your audio is actually a continuous signal. It's just a function of time that has value at every single point in time, right? As you speak, and then if you record that and be able to see it as a function of time, you will see that it is a continuous function of time. However, computers do not know how to deal with continuous values. Why? Because continuous values in any range contains infinite amount of values, right? And to store infinite amount of values inside a computer and be able to deal with them requires a computer that we cannot do as human beings, okay? So the only option when you are dealing with computer is that this voice that you have spoken or tried to record is going to be converted and stored in the computer as some discrete set of values. Okay? And you will notice that whatever tool you will use, there will be something called sample frequency, okay? And or sampling time. Like the dual of this is sampling time, okay? Either called FS or this one is called TS, okay? The sampling frequency or the sample frequency is in 1 second how many values of that continuous signal you are picking, okay? So in 1 second of your voice, if I take 1,000 values, 1,000 discrete values, this means that my sampling frequency is 1,000 hertz. Okay? So I'm taking number of samples within 1 second. So this is equal to, by definition, the number of sample values read from a continuous signal in 1 second. Okay, so if this is your signal, if this is your voice, right, as a function of time, okay, so this is your x of t, your voice, okay, then if this is 1 second, for example, and I've taken 1, 2, 3, 4, 5, 6, 7, 8, 9, for example here, then my Fs here within 1 second, this is 1 second, Fs is equal to 9. That's the number of samples that I've taken from this signal within 1 second. Okay? Because I cannot read all these values, it will require infinite memory to read them. So my only option is just to pick some values, and they are always picked at fixed interval. So I don't just pick one at, for example, 1/9 of a second, and then the next one I take it at 3/9 of a second. No, it's just 1/9, 2/9, 3/9, 4/9. So they are always picked at fixed interval, and that interval is Ts. So in this case, Ts becomes simply 1/Fs. So the duration between one sample and the other, called sampling time, is just the inverse of the number of samples, because they are taken at fixed intervals or fixed separation intervals, okay? Now this is something that we will not deal with in terms of what is a good value and what's a bad value. We will touch upon this later on when we go into the part about sampling. I told you that this project will also touch upon when you do sampling. But be aware that whenever you are recording your audio into the computer, yes, come in. Whenever you are recording your audio at the computer, whatever recording tool you are using, whatever software, MATLAB or anything else, you will find that parameter and it has a default value. Most of the time it's 8,000 samples per second. Okay? That's the default value. That's default, but it's not the only possible value. You can change that, you can increase it, you can decrease it. What is a good value? We will discuss that later on when we talk about sampling. Yes, what's your question?
A signal can be negative?
No.
Then why? It's not like in the negative part.
I didn't say where is 0. I was careful about that.
Okay.
So it doesn't mean that 0 is here. I didn't say this is 0. Okay? Just showing the two axes, that's it. Okay? What were you talking about? Okay. So that's one thing, one parameter to keep it in mind. Okay? But anyways, your signal is going to be taken, converted into discrete signal, and then after that you start processing it. And unfortunately, in this course, we are studying when we move from time domain to frequency domain, and we move from frequency domain to time domain, we are only focused in this course on continuous time signals, right? However, MATLAB or any other tool that you use on the computer does not have that option. It simply deals with the discrete time case, or the digitized case, or the sampled case, okay? And when you are looking at frequency domain representation of discrete time signals, there are differences in the operations that you have to do. It's out of the scope of this course, okay? But we will touch upon the points that allows you to use MATLAB to get your frequency domain representation correctly and to look like a very good approximation of what you have got if you calculated it using the continuous time representation, okay? The details of actually dealing with discrete time situations is going to happen in your next course in signal processing, the DSP for computer engineering, and the signals and filtering for electrical engineering students, okay? So this is where you will study really more details, mathematically and in depth about the discrete time case, okay? So again, after you record your signal, the next step is going to be, again, you can plot the signal, and I will show you, by the way, example code that allows you to do this very simply, okay? So after recording your signal, you start looking at, like, plot the time domain. Okay, I warn you, when you plot the time domain, you will see a graph like this in MATLAB, right, as a function of time. And this is your voice or x of t or whatever. But reality is, again, MATLAB is just giving you an illusion that it is a continuous signal that it's dealing with. But reality is, it's actually just pixels, dots, right? Because it only has discrete values of the signal. Because it only deals with sampled version of the signal. But if they are close enough and you have high enough sampling rate, then it will look to your eye as, and that's why I call this a good approximation of the continuous case. That's up to this, it's straightforward. Now the next is get the frequency domain representation. Okay? And in that case, in our previous slide or in today's lecture, we talked about the Fourier transform. Unfortunately, Fourier transform cannot be calculated by MATLAB, the actual Fourier transform, but it has something called FFT function, the fast Fourier transform function. This function, f of t, when you give it a time domain signal, it produces the frequency domain signal. So if you give it x of t, right, it will produce here x of, supposedly, x of omega or x of f. Again, you can write this as a function of f. The relation between f and omega is 2 pi, in fact. So f multiplied by 2 pi gives you omega, okay? But it does this for the discrete case. And there are some differences in terms of the calculation. Because of those differences, you need to do 2 operations to see a correct spectrum that represents the continuous case. Those 2 operations are, number 1, okay, remove the mirroring effect, okay, happening because of periodicity assumption. And I will tell you what I mean by this. Okay? And number 2, represent the values on the f or omega axes correctly. Okay? So remove the mirroring effect and represent the values on the frequency, not f of omega, frequency or omega. Let me put this in a way which is not confusing. Frequency or omega, okay? I will just write it as or, because now I'm afraid you will think it's F divided by omega. F or omega, okay? Like as a function of F or a function of omega, it's the same. So you just need to represent the values there correctly. The reasons for those, it comes from when you deal with discrete situation, there is an inherent assumption, because that's what happens when your time domain signal is discrete, that in the frequency domain the signal will become periodic. Okay? And again, because when we deal with the frequency domain representation of any time domain signal, we cannot deal with the continuous. So if for any reason the frequency domain signal is continuous, MATLAB will not be able to deal with it. So there are two things that happens when you are using the f of t. There is an inherent assumption that your input signal is periodic, even though it's aperiodic. So whenever you give it a signal, for example, 1000 value, right? It assumes that they repeat again and again and again. So, okay? And not only that, it also assumes that the output coming from here is going to be a certain number of values, and then those values repeat again and again and again. Because this is the only way, and don't worry about this explanation, it's just for your understanding. This is the only way that it can keep this as discrete and this as discrete, because they are both values that MATLAB has to deal with. So the only way to be able to do this is to assume that this is periodic and this is periodic. Okay? So both of them will become discrete. We don't care. You just need to correct for this situation by doing those two actions. Okay? And I will show you, I'll flip now to the code itself, and I will show you how this happens on MATLAB. So you can overcome